welcome and thank you for joining. My name is Emeka. I'm a senior software engineer, and today I'll be talking about software craftsmanship and writing maintainable code. This session is based on real-world experience, being in the industry for a while, working and growing engineer teams, where code base expand, complexity increases, and small design decision compounds over time. We'll explore how writing clean code, maintainable code, help reduces technical debt, prevent burnout, and build system that scales sustainably. My goal today is to help you shift from simply writing code that works to writing code that is clear, safe, and built fast. And built to last. Yeah. The agenda for today. So by the end of this session, you should clearly understand what maintainable code actually means. Not just code that works, but code that is easy to read, easy to modify, and easy to extend over time. You will learn practical techniques for writing cleaner and more readable code, focusing on naming and structure and simplicity, which is very important. We'll look at common code smells, warning sign in code, and how to recognize and fix them before they become serious technical issues. You will gain a working understanding of dry and solid principles and how to apply them correctly in real projects, not just in theory. Finally, you will learn how to refactor legacy code safely and incrementally without breaking existing functionality or creating risk in production. Software craftsmanship and writing maintainable code. Maintainable code is code that other developers can easily understand, modify, and extend without fear. If you have a code that nobody is able to modify and they're scared because for some reason the code is so difficult, poorly written code, which increases bugs, stress, and technical debt. Clean, well-structured code reduces friction and improves team productivity. The goal of this session is to shift your mind from just make it work, the idea of when you're coding, you just want it to work, to make it clear, maintainable, and sustainable. Software craftsmanship means treating development as a profession, not just a job where we could complete tasks and move on. It requires prioritizing quality, clarity, responsibility. We are accountable not just for delivering features, but for how we deliver them. We write code for future developers, including our future self. If you revisit your code in the next 6 months, it should still make sense to you. The problem is if your code is badly written, if you visit your code that you wrote maybe 6 months ago and you start finding it difficult, something is wrong. And that's what we need to talk about today. Finally, craftsmanship is about balance. We must deliver quality, but not at the expense of long-term sustainability. Speed without structure also creates chaos. Why maintainable code matters? Code is read far more often than it's written. Every feature, every bug fix, every enhancement requires someone to first understand the existing code. If you have new person in your team or whatever, you need to understand how it works, and you often do this by looking at the code. Poor code increases bug because unclear logic leads to incorrect and assumption and fragile fixes. Over time, this leads to development burnout, constant firefighting, fear of changes, and slow progress. It increases delivery speed because developers spend less time deciphering logic and more time in building the actual stuff. Common problem in real world code bases. Large confusing functions are one of the most common issues, like all those very long functions, very large functions. When a function does too many things, it becomes difficult to test, to debug, and modify safely. When your function is very large and is doing a whole lot of things, poor or misleading naming creates constant cognitive load. Developers spend more time guessing intent than solving the problem, because the names you're using are just confusing. Maybe you have a variable called a, just a, so something like that. It's misleading. Duplicate logic everywhere is a major source of inconsistency. When you're duplicating things, you have different logic, the same logic, but in different places. That's a duplication. Tight coupling between components make the system fragile. Changing one part unexpectedly breaks another. Eventually, teams develop fear of touching existing code when developers are afraid to make changes, and this will slow things down and technical debt grows rapidly. Yeah, clean code and core principles. So clean code start with readability. If someone can look at your code and understand it quickly without extra explanation, you've done well. Simplicity is key. Each function, class, or module should do one thing and do it clearly. Complexity is often the root cause of bugs, like when you're over complicating things instead of making it simple. Yeah, you're trying to like prove that you can do this better. Maybe you're writing better or something, and it's just something that requires one line of code and you're overcomplicating it. Right? Predictability means that the code behaves the way developer expect. Surprisingly, behavior leads to subtle production issues. Consistency means more than personal style. Following agreed pattern across the team reduces confusion. You join a new team, you look at their code, you have your own style, but instead of bringing in that your style immediately, you could adapt to what is existing, what the team is currently doing, their style of coding, which I believe if it's good enough, you should follow that. If it's not good enough, maybe you have something that you need to plan if you want to refactor that. Ultimately, clean code is code that another developer can understand easily. If someone else can confidently modify it without asking you questions, that means it's a clean code. Naming is arguably the most important skill in programming. Good naming reduces the need for comments and explanation. Use clear intention. Revealing names, a developer should understand what a function or variable does without reading it entirely, entire implementation. Avoid abbreviations, and guess work. Short name saves second, while writing but costs minutes of hours when reading. Yeah, all those short names like something like rec, something like a, just instead of maybe it's actually maybe you want to write something and you just abbreviate them. When someone is reading, like the person, it's hard to read to understand what you're doing. So avoid abbreviations. Functions should describe what they do, not how they do it. The implementation should be hidden inside. Looking at bad example, at the bad examples, we have like process. You see the process there. It's by looking at it, it could mean a lot of things. So if I'm using this function, it doesn't really clearly state on what I'm using. This function is all about. You have a function, you have a variable called data1. What exactly is data1? I mean, it could be anything, so it's confusing. So imagine having data1 all over the code and someone needs to like going over to trying to understand what data1 contains. So handle stuff. Yeah, a lot of people will have function names and methods like handle or handle stuff or stuff like that. They don't tell us anything about the purpose. The good examples of good methods, good names, calculate total price. Yeah, by looking at this, you know, this function will calculate the total price or whatever it is. User repository, send password, reset email. It's clear that this function is just for sending out password reset email. So when I call this function, I expect an email to be sent out. When naming is clear, the code almost reads like plain English. Anybody can read your code, just reading it. Yeah, and that's the goal. Functions that are easy to understand. The good functions are small. The smaller the function, the easier it is to reason about and test. A function should do one thing and do it well. If you find yourself using "and" in the description, it's probably doing too much. So you have a function that is doing too much. Keep parameters minimal. If you have a function that has way too much parameters in it, too much parameters often indicate that the function has multiple responsibilities or unclear boundaries. So you probably need to break that function into smaller units. Function should be should read like a sentence. When someone scans the method and call them, they should understand the flow of logic immediately. The rule of thumb is simple. If you need a comment to explain what a function is doing, it likely needs refactoring. Having comments. Comment is good, but yeah, you need to be careful. If you have a comment explaining how a function works, for example, that function is probably not good enough and needs refactoring. A clear structure reduces mental load and makes future changes safer and faster. Comment should explain why and not what. Yeah, your comment should just explain why and not what. The code already shows what it's doing. Comments should clearly clarify intent or reasoning. Use comment to document business logic. Sometimes logic reflects domain-specific decisions that are obvious from the code itself. Comments are also useful to warn about non-obvious behaviors, edge cases, performance trade-off, or legacy constraints. Avoid comments that simply repeat the code. If the comment says same thing as the line below, it has no value. Never use comment to justify poorly written code. You are trying to like use a comment to explain, oh, this code is written this way because I could not figure out this or that. If something needs heavy explanation, is probably it needs refactoring. Be careful with comments that can become outdated. Incorrect comments are worse than no comments because they mislead future developers. The goal is clear code first. Comment should support clarity and not compensate for confusion. Yeah. Um, Code smells. Code smells. What is code smell? Warning sign. Code smells are signals. So they are not errors. Um, they don't necessarily mean the system is broken, but they indicate area that may cause problem later. Long methods are difficult to test and understand, which are common code smells, having large classes, duplicate code. Deep nesting makes logic hard to follow. The more indentation you see, and it becomes to reason about the flow. Too many responsibilities and single module makes the system lightly coupled. The key is to treat code smells at early warning sign. Addressing them prevent technical debt from compounding. Identifying technical debt. Technical debt often reveals itself through behavior or non-metric. When someone says, don't touch this file, that's a strong indication of accumulated debt. So this debt is all about, like, instead of writing a code that will stand the test of time, you just write something quickly just for that time, or just fixing that issue. And you're not writing for the future. So this is debt, because along the line, you still need to come back to that. It could become a problem. You need to fix that. You need to really do the actual work. Slow development speed is another signal. If simple changes take too long than expected, the underlying structure may be fragile. Frequent regression suggests that coupling or unclear logic, fixing one issue intentionally breaks something else. But it's important to remember that not all technical debt is bad. Sometimes shortcuts are strategic. The real problem is unmanaged debt. Yeah, sometimes you just want to quickly fix something, maybe hot fix for the production. Yeah, you can do that, then go back and do the actual work and deploy that just to prevent technical debt. Refactoring. What is refactoring, and what it's not refactoring? Refactoring is about improving the internal structure of the code, making it clearer and easier to maintain. The key rule: refactoring does not change the external behavior of the system. The software should still work exactly the same. If you're refactoring something, factoring is not adding new features. Like if you say you want to refactor something and you find yourself adding new features, you're not refactoring. You might end up breaking stuff. Refactoring should not break anything. The goal is to make the code better and better today, so that future changes are easier for tomorrow. Safe refactoring strategy. So the first rule of safe refactoring is ensure test exists. So yeah, many people just have this code written without test, which is very bad. You need to adopt test-driven development in the first place, which is very important if you really want your code not to break and stuff like that, giving you nightmare in production. You need to have proper tests, probably have them in your pipeline running, so that you ensure the test is enforced before all the tests run and pass before deploying to production. If there are no tests, then before making structural changes, things can just break without you knowing. Um, Makes more incremental changes when you want to refactor stuff. Large changes increase risks. Just make incremental changes, just a little bit of change there, here and there. Then probably write test, run the test, make sure nothing is broken. As long as your test covers those changes you made as well. Um, Commit frequently, yeah, when you're refactoring stuff. Small commits makes it easier to track what changed and revert it if necessary. So don't just wait and make one big commit. Make small commit frequently as you're doing your refactoring. Continuously review and validate your changes. Run test often is change. Run test, make sure nothing is broken. Safe refactoring is key to not breaking anything in the code base. Dry. What is dry? Dry means don't repeat yourself. Dry means avoiding duplicate logic, repeated business logic. If same business logic exists in multiple places, it increases maintenance effort. The goal is to create a single source of truth. When requirements change, you update one place, not 5 places, not 10 places, not all the places. If you find yourself using find and replace to look for or where all this is, for example, maybe you have a formula for calculating sales price due to cost price or something like that, order price. You have this function all over the place, duplicated. If you find yourself looking for those functions just to make changes, like is a very bad code. Following the dry principle. Sometimes duplication is acceptable temporarily, yeah, probably when you're just exploring requirements. The key is intentionally don't you just want to test things out. Duplicate code should be removed when you're done, when everything is stable. You kind of refactor it, removing all the duplicates. Yeah. Solid principles overview. What is solid principle? Solid principle is just a set of 5 design principle that help us build flexible, maintainable, and scalable system. Single responsibility principle. A class should have one reason to change. So this in principle focus on a class. When you're coding a class, you have one single responsibility. If you have a class that has multiple responsibilities, it's breaking this principle. And these principles help us to build flexible, maintainable code. So these are something that you need to take seriously. You have open close principle. Software entities should be open for extension but closed for modification. We should extend behavior without altering the stable code. We have list code substitution principle. Subtypes should be replaceable with their base types without breaking behavior. We also have interface segregation principle. Clients should not be forced to depend on interface they do not need. So you have a class interface. You're using one interface. You have an interface that, for example, let's take, for example, a car, right? So you are using the same interface for bicycle, for example. A bicycle has different functions and the car have different functions. So you need to segregate these functions into different interfaces. And we have dependency inversion principle. So high-level models should depend on abstraction, not concrete implementation. So together, solid principle reduces high coupling and makes system easier to evolve over time. Talking more about single responsibility principle. which is very important. Single responsibility states that a class or module should have one reason to change. This means it's focused on one's responsibility. When a class does one job well, it becomes easier to understand. So if you have a class that simply sends an email, for example, it is clear this class is just for sending email. So any changes you need to make on this class is about email. So if a change in the business rules affect multiple unrelated parts of the class, that's usually a violation of this principle. A common smell is a class that handles business logic, validation, login, database, persistence at all once. Like you have a class doing all these things. It means there's a problem. It's not following this principle. When responsibilities are missed, small changes can cause unexpected side effects. So you're going back to fix the validation logic. You're fixing the login, or in this class, you're going to end up breaking things. Separating concern leads to clearer architecture and safe refactoring over time. Open close principle. The open close principle means one code should be open for extension but not closed for modification. In practical terms, we should be able to add new functionalities without changing stable existing code. Modifying existing code frequently increases the risk of introducing bugs. So this principle will help us to avoid this. Instead of changing core logic every time, requirements evolve, we extend behaviors through abstraction and interface. This is often achieved using interface strategy patterns. For example, instead of modifying a payment processor class for every new payment method, we introduce a common interface and implement new strategies. The goal is to reduce ripple effects and make the system safer to evolve over time. Dependency inversion, practical overview. Dependency inversion means we depend on abstraction such as interface rather than the concrete implementation. Instead of a class directly creating or tightly coupling itself to another specific class, it should depend on a concrete. This makes the code easier to test because we can substitute real implementation with mocks or stubs. It's even easier to test when you're writing your test. It makes component easier to replace if the implementation changes. We do not need to rewrite the dependent code. We just provide new implementation of the same interface. Overall, this reduces tight coupling and improves flexibility. In modern framework, dependency injection container helps to enforce this principle by resolving dependencies through abstractions. Writing code for the team. Are you writing code for the team or are you writing for yourself? Software development is a team activity. Code is a shared asset. It doesn't belong to you, it's not your personal property. Consistent style is more important than personal preference. You of course, you prefer doing it this way, but you need to be consistent with what your team are doing. So your team agreed on specific, the way you handle your naming structure of maybe naming conventions, the structure formatting, architectural pattern. Probably you're using a framework or something, and you need to follow that framework. For example, they're using something like Laravel, and you need to follow the way Laravel does things, the naming conventions of Laravel. For example, the model classes, they are capitalized and first letter capital. You need to follow that, right? And you don't need to come changing that to lowercase or fine. because that's your preference. You just follow the convention your team is using. Always aim to leave the code better than you found it. And even small improvement accumulate over time. The goal is collaboration, maintainability, and collective ownership. Code reviews as craftsmanship tool. So we're talking about code reviews. Code reviews are not just quality gate, they are learning and improvement tool. Good code review focus on clarity, correctness. The goal is to improve the code, not criticize developer. Of course, you have junior developers, don't attack anybody, focus on reviewing the code, and also a junior developer grow fast when reviews are constructive and educational. Over time, consistent review help improve and shared standard across the team. So when reviewing code, code reviews reinforce craftsmanship and collective ownership of the code base. Junior, mid-level growth mindset. What I mean here is moving from it work to it's clear, safe, and maintainable. Yeah, shifting from that, it works. The transition from junior to mid-level developer is largely a mindset shift. As a junior, the focus is often like it works. They just focus on getting the code to work, the outcome. If the feature runs without error, the job feels done. At the mid-level, the question becomes, is it class? Is this safe? Is this code really maintainable? The concern shifts from just functionality to long-term quality. Thinking long-term means considering how this code will evolve over months, over years, over time. Anticipating change means designing the flexibility in mind. Requirements will change and the code should still adapt frequently. Writing for others means recognizing that your teammates and your future self, when you get back to that code in the next 6 months, that you still be able to understand it and modify it without breaking stuff. Growth is not just about writing code, writing more. It's just not about like you're writing a lot of stuff. It's about writing better. It's about writing safer, and it's about thinking about what you're writing, writing the correct thing. A practical takeaway is clean code is not something you do later. It's a daily habit. You need to do this daily. Once you start working, once you get coding, think about it. You need to your code needs to be clean. Every small decision, every structure, every clarity contributes to long-term quality. Small improvement compounds over time. Refactoring a function today may seem minor when you're doing it, but repeated consistently, it transforms the entire code base. Refactoring is part of the development, not a separate fix. We improve the structure continuously as we build features. Maintainability is a team responsibility. It's not just architect's job or the senior developer's job. Everyone contributes to code quality. The overall goal is sustainability. We want the system that are easy to change, easy to understand, and easy and safe to evolve. Yeah. That's it. We covered today. We've covered the principles, patterns, practical strategies for writing maintainable code. So now the floor is open for question. If you have any question, you can send them to me. Thank you for your attention and engagement throughout the section. Thank you.